In the Northwind sample, each order can have several detail records associated, which represent the individual items or products linked to the order. The out-of-the-box functionality provided by OnTIME App Generator allows us to create new rows on the order page, search for a product using the lookup, set the price, quantity, and discount, and insert the record. For certain workflows, this works great. However, we may want our users to view all possible combinations at once and be able to use datasheet mode to fill in values as necessary. Let's learn how to set this up using the OrderDetails child data view as an example. Let's go ahead and create our data pivot project. Let's connect to our database. Next, let's set up our models, starting with orders, customers, sorting by company name, employees, sorting by last name, shippers, sorting by company name, order details, categories, sorting by category name, products, sorting by product name, suppliers, sorting by company name. We'll remove the homepage field. Next, let's bind order details as a child data view on orders. Let's keep pressing Next. And open the Project Designer. Under Controllers, drag and drop order details onto orders. Also bind it to Edit Form 1. Go ahead and browse the app. We can now view a list of related order details on the Orders screen. First, we will need to set up a new data controller that will capture user input and insert, update, and delete records as necessary. Let's open the Project Designer. Let's create a new data controller called OrderDetails Menu. From the OrderDetails controller, let's copy some fields. We'll copy Order ID, Product ID, Product Name, Product Category Name, Product Supplier Company Name, and Quantity. Let's mark the Quantity field as optional. We'll want to right-click the OrderDetails menu controller and select Generate from Fields. This will create a baseline set of views, actions, as well as business rules designed to overwrite the standard CRUD operations. Next, let's add Order ID field into Grid 1. We'll want to bind OrderDetails menu grid onto the edit form of orders. Let's copy the OrderDetails menu controller and paste it on the orders controller. This will create an OrderDetails menu data view field. This controller is not based on a real database entity, so we'll need to manually configure our filter field and set it to Order ID. Next, bind OrderDetails menu data view field on orders into Edit Form 1. We'll want the user to be able to see the traditional OrderDetails view when the form is not in editing mode, and view our custom OrderDetails menu grid when the form is in edit mode. This expression will be written in JavaScript. Let's go ahead and generate our app. When we view an order, we can see the standard OrderDetails view. When we edit the order, the view is replaced with OrderDetails menu. This OrderDetails menu view will allow us to provide a custom implementation to download, insert, and update records to work in a pivot fashion. Let's make a few customizations to OrderDetails menu. Under Orders, let's tag the data view field as inline editing to enable inline editing by default. Under the OrderDetails menu Grid 1, let's drag Quantity to be the first field. Let's mark Product ID as a primary key, and we'll hide it from Grid 1. Finally, set the page size of both OrderDetails and OrderDetails menu data view fields to 30. Let's see our changes. When we edit our order, we now have quantity in the left column. We'll see our other changes as we proceed through this video. In order to populate the list of order details to reflect the full list of products from the database, we'll need to write some code to populate the rows of order details menu. This code will be placed in the Select business rule. So let's go ahead and open it in Visual Studio. Notice that the default implementation of this getData rule will create a data table object and assign it to the property resultSet. This data table has been provided with the columns defined in the controller. First, we'll need to go ahead and fetch a list of all the products and add these as rows to the data table. In order to ensure our rows aren't filtered out, we'll need to set the order ID equal to the currently filtering order ID. Let's go ahead and create a new SQL query. For each row that we return, we'll create a new data row from our data table, and we'll assign the fields as required. Finally, add this row to the data table. Let's go ahead and try debugging our new code. First step, we'll select the current order ID based on an external filter. We can see the order ID is populated. Then we'll use the query to select data and provide a new row. This is the current row from products. And we'll iterate for every product in our database. Let's see it in action. Notice that we now have 77 rows of order details menu items, representing one row per product in the database. The quantity field is null for now. The next step will have us populate this field based on existing order details records. There's one small problem with this code. This code is called every time the grid is refreshed or any changes are made. It is unlikely that new products will be appearing all the time, so we'll consider caching for 5 minutes. This way, requests will not be slowed down by continual database queries. We can use the HTTP context cache feature to store our structured data table. First, we'll need to check to see if we've cached the data table already. If the data table is null, then we'll run our code to build the data table. we'll want to move the order ID initialization later. Once the data table's been built, then we'll save it into the cache. After we've pulled up our data table, we'll want to start working with a copy to not modify the one we have in the cache. Next, let's iterate every row in this copy of the data table and set the order ID. Let's go ahead and drop a breakpoint to learn how this works. And let's start debugging. The first step will be to try to pull the data table out of the cache. The data table is null, so we'll go ahead and reconstruct it. Once we've constructed the table, we'll add it back into the cache and create a copy. Then we'll set the order ID of each row and return the data table. We can see that the Order Details menu works as before. When we refresh, there's no delay. The next step will be to go back and fetch the quantity of specific products relating to the current order by querying order details. First, we'll need to build up a map that maps each product to a specific quantity. We'll create another query and we'll use an anonymous C# object to pass the order ID. For each row, we'll build up our sorted dictionary of mapping from products to quantity. Now that we have a mapping of product IDs to quantity, we'll want to pull up the quantity for each product as we iterate through the rows. If we've found a quantity for that specific product ID, then we'll set the value. Let's go ahead and try debugging. First, we'll create a dictionary. Then we'll select all the order details based on the current order. For each item, we'll store it in the details dictionary. We can see that product ID 11 has quantity 12. Next, for each row, we'll see if details has that specific product ID, and if it does, then we'll provide the quantity. Let's see it in action. We can see that this order has 4 order details. When we press Edit, we can see that the quantity is populated for the relevant product. If we go ahead and try to edit using inline editing, notice that the value is cleared after we try to save. We'll need to implement our update business rule to correctly insert and update detail rows as necessary. For this business rule, let's use data access objects. Let's enable data access objects for the OrderDetails controller. Once enabled, we'll need to browse. Once generation is complete, let's open the Update Business Rule for OrderDetails menu. It may be necessary to refresh your Solution Explorer to pick up the new data access objects. We'll want to keep the Prevent Default to ensure that the library does not try to write to the database automatically. We'll be doing that ourselves. First, we'll go ahead and see if there's an existing order detail row in the table. Next, we'll check to see if the quantity is null or equal to 0. If quantity has a value greater than 0, and the existing detail does not exist, then we'll insert a new record. If there's an existing record, then we'll update the quantity Otherwise, we'll delete any existing detail row. Let's go ahead and try debugging. Let's try setting a quantity where the quantity was null before. First, we'll try to select an existing detail. The existing detail has not been found. We can see the quantity does have a value that is greater than 0. The existing detail was not found, so we'll insert a new row. If we try to update a quantity, then the existing detail object will have a value. We'll update the quantity and update the record. If we clear the quantity, we can see the quantity does not have a value, and an existing detail exists, which will be deleted. Let's try it out. Let's go ahead and set some quantities. We can also update a quantity, and it'll update the existing row. If we clear a quantity, or set it to 0, those records will be deleted. This provides us a pivoted presentation of all the products associated with a certain order.